And we're going to take a minute to just talk about squeegee pressure. So squeegee pressure can be divided into two. We did an earlier video on how the travel is different to the pressure. So if we're looking at pressure, all the pressure is controlled from this valve here. We can open and close the valve and reduce the amount of force, muscle, power that is used to travel the set distance. Plastisol ink will practically print at 3 to 6 bar. So when we first get to the machine is regulated. So if your compressor is picking out 7 or 8 bars, there will be a regulator on press that brings that down. And so we only hit about 6 bar at the print head. What this means is we can see quite clearly on the dial where we are set. At 6 bar, we're using all the available force, muscle, power, pressure. This will be sufficient for a thick, cold plastisol through a high mesh count. Once we get accustomed to how this press operates, we can reduce this pressure. And this pressure, we can dial all the way down to around about 3 bar. We can see the dial changing in real time. So here we know for a fact that we can print up to about 3 bar, and with some water-based inks which have less of a body, we can get all the way down to about 2 bar. The reason for this is to finally control the print detail. Less power is less opacity, but also more detail. So we can use it on 4-color process, on CMYK, on simulated process, and to help us avoid that printer's worst nightmare, that sticking of wet ink, when we're using excess force and excess pressure, then we can use that adjustment to dial back that pressure and act with a little bit more finesse. The travel is controlled by these 2 black wheels. So the travel is labeled front and rear. The reason it's front and rear, if you watch the previous videos, is the press doesn't care where you put the rubber squeegee and where you put the metal flood bar. It doesn't matter to it. So we have an independent control for the front and independent control for the rear. In this configuration that I have set up, the rear is the flood bar and the front is the squeegee. So when we're printing, we really want to find the minimum amount of pressure we need. So we can do this by taking the print to failure. So when we take the print to failure, we will take a print and watch in here to see whether we're getting good clearance. Now this cleared reasonably well for a cold plastisol print. So we can reverse and back off this pressure. I work in 3s, this gives me a good chance to be able to correct any mistakes. So if this doesn't work, I can go back 3. We can see that the ink is still clearing, we've got good clearance, we've got good squeegee bend, so let's try and find that failure point. And there we have the failure point, the point where the squeegee is no longer traveling enough distance to come in contact with the palette and the shirt. So because we were working in 3s, we come back 3. And here, I now have my absolute minimum failure point. I know if I take 3 off that, it doesn't work. So I found my minimum. I can also then release the air down to the point where I think it won't work. And again, we'll watch the squeegee print. Now this reading is on 3 bar. Now at 3 bar with minimum travel, it still prints. So that tells me I don't need 6 bar. I don't need the extra 6 turns on this wheel here to achieve minimum pressure, minimum ink transfer. I want to keep all that nice bright white ink that I paid for on the surface of the shirt, not on the inside of the shirt.